Hey, good afternoon, everybody. How many people do I have here that are actual developers? And by developers, I mean you can be a prototyper, you can be an enterprise developer, hey, you can write Python, you can even write really good batch scripting. Awesome, awesome. Then this talk's for you. How many people do I have in the house that are security professionals of any kind? Awesome, this talk is for you. And how many of you think that your developers in your environment have a lot of access that they probably don't realize that they have in their environment? Awesome. So you already know this talk. So I'm just going to regurgitate some stuff that you're already knowing or maybe you're thinking about. And then let's kind of talk through how we use that from a red team perspective or from an attacker's perspective to where we can get exponential rates of returns from these types of attacks. So once again, my talk, it's about using the developers as a tool. Because why should I try to infect every single one of you out here if I know you all use Slack? Why don't I just infect the Slack app if I can? And if I can infect that Slack app, then guess what? I'll get you over time. So that brings this to why you should listen to me, right? I'm Brandon Helms. My Twitter handle is Chiefy Chief. I'm our Chief Operations Officer at Rendition InfoSec. But remove the title from my name. What do? I do red teaming operations, exploit develops, do things person, right? Kind of like a lot of people in here. As a developer, you're probably wearing multiple hats. You're probably not just sitting on a keyboard typing, and if you are, that's the awesomest job in the world. You're probably also having to kind of engineer, try to take people's thoughts and translate them into beautiful front ends or into beautiful applications that do things. Outside of that, I used to be in the Navy. I was a crypto logic technician for the networks. I ended up making chief, worked at a few three-letter agencies, did some really cool things. And then lastly, I am a gymnastics dad. So from my development perspective, I was able to see the development practices at multiple three-letter agencies, at the Department of the Navy. I worked for a company called Palantir, so I got to see the enterprise side of it. And then even at Rendition InfoSec, I get to see our security practices and our best practices for programming. So I took all of those and I said, hey, where are we getting it right? Where are we getting it wrong? Which now takes us to this piece. Talking about supply chain interdiction, right? This has kind of creeped up over on us for the last 2 years, but really this has been happening all along. Just people are getting smarter. Turns out CEOs are losing money, so that's why it's more important now. So in order to know about using software for supply chain interdiction, we're going to talk about the traditional supply chain interdiction. We're then going to move to applying that to our software models now to get those exponential results. Afterwards, we're going to take a step back and talk about why we got here. So understanding the mindset of the developer, everybody in this audience. Because at the end of the day, you're just trying to do the best you can with what you have. And many times those pressures that are put on you create these environments that create this surface area of unnecessary risk. We're going to then go into the attacker's mindset and how, as my red team at Rendition InfoSec, we use the attacker or we target the developer to be able to get us to get these quantifiable rates of returns. So with that, traditional supply chain. So when we start thinking about this, we start thinking of, hey, I'm going to insert my company in a impoverished country. I'm going to have a sweatshop. I'm going to be able to churn out these shirts that are dirt cheap. I'm going to get them into Walmart's stores because I'm going to do something that's going to make me have that competitive advantage. Whether it's something malicious, something illegal, or I'm just going to underbid everybody because I can. At the end of the day, it's for the competitive advantage. Right? So, in order to do that, we have to get creative. If I want to get into these supply chains, I'm going to have to find something that entices you. Once again, if we go back to that shirt analogy, what's going to entice Walmart to buy my shirt over somebody else's shirt? If I'm going to say the same exact shirt, because Walmart's just going to sell it as a white shirt, and they're going to slap some logo on it. Right? They're going to say, hey, is your price cheaper? Can you give me more quantity? Hey, can you make it worth my while? So that's why we do things to be able to say, hey, I have a company over here. To build that company over here, it still costs money. You get a one-for-one return, right? In order to get those people in the sweatshops, you have to invest. To be able to get yourself into that supply chain, you have to invest. So where you do get your shirts there, it's still a very long and tedious process and a costly one. But it has paid off, right? We'll take AT&T, for example. Who here remembers when the first iPhone came out? Yep. How many of you were not an AT&T service member at the time? Did anybody swap over to AT&T at that time? Oh, good answer. Last time, everybody's like, yeah, I swapped over to AT&T. Yeah, I was on T-Mobile at the time, and T-Mobile sucked really way back then. But long story short, AT&T got exclusive rights to the iPhone. iPhone was the first smartphone, although I think Microsoft did it a few years before that. But when they came out, everybody wanted them, and they had that competitive advantage. So as the iPhone price went up, AT&T went up. That's that competitive advantage that I'm talking about. There's nothing malicious about what AT&T did. They just got the upper hand. But what happens if we take that same perspective and apply it to some of the things we've seen in recent years, such as their accusations from The Guardian that the U.S. has been involved in supply chain interdiction? If you think about it from a U.S. standpoint, we have some of the biggest companies here. We have Microsoft, we have Cisco, Apple. You pick one of the big Fortune 100 companies, they probably headquarter in the U.S., meaning that we have many points of egress that we could interject that piece of hardware and do what we want to it, right? We say that's far-fetched, right? But then we heard about this thing called Supermicro in China, right? And what did we find? We found out that these little tiny semiconductors actually had targeted instructions on it that said, hey, if this goes somewhere, do this. And then everybody freaked out because now it's no longer theoretical, it's now practical. We have tangible evidence, we have proof, we're now reversing it. If you want the slide deck, you can have it, and it'll walk you through every step of how this was done. So now we're no longer in the realm of theoretics. We're now in practicality. But once again, in order to do this, this took a lot of research, a lot of design. They had to embed themselves in the right place at the right time. And from a physical standpoint, that's tedious. That's very hard to do. But let's start thinking about software, right? Do I need to have a physical location to compromise software? No, I just have to compromise somebody who has access to that software. So from the software side of the house, it's scalable, meaning that if I infect your application, then any client that you have that browses to that application is now susceptible. So if you build a web app and I inject on your web portal, then anybody that browses that web portal now can be compromised by me. Once again, this was thought to be theoretical a few years back, and everybody's like, oh, that doesn't mean much. But then what happened? Shadowhammer, right? Does everybody know about this, the ASUS Live Update, or you might call it a SUS, the update utility? What happened? Summoned everything up. Basically, attackers got into the development environment. They were able to take a small bit of code, highly targeted, and inject it into the process of the developer. The developer somehow got that code to their master, their production instance, in which it went out. And as people got this live updater software, they now were infected indirectly by the attacker's maliciousness. Does that make sense? Perfect. Another one that I was very disheartened about was CCleaner. I've been using CCleaner for better part of the last decade, right? Once again, same concept, right? Malicious attackers got it in. They inserted a little bit of code into the actual code base. The code base made it to production. That one compromise there got 2.3 million downloads, known downloads, with over 700,000 systems infected. So if you said, hey, as an attacker or as a red team, I want you to go infect 700,000 people, that's going to take forever. If you say, hey, infect this piece of code and let's see what comes back, the rate of a return is exponential. This is why we love going after the developer. So I just stated what the problem and what the people are doing to attack that vector. Let's talk about the actual developer. I saw that I had a bunch of developers in here. How many of you are told that, hey, we're going to operate off an agile workflow? How many of you are told we're going to do sprints? How many of you are told, hey, we're going to do feature release, then bug release? And then how many times are like, oh, we're behind. I just need all these features. We'll get to those bug releases later, right? We're not going to rebase. We're not going to go back. We're going to keep going forward and forward and forward, and you're going to keep getting pushed and pushed and pushed, right? I know this because I've been at 3 different product companies that do 3 different things, from prototype to enterprise development to everything, and all 3 of them are push, push, push. Once again, it's no malicious intent. It's just we got to get the product out there. You developers are one of the most valuable resources to a company. So if they say, hey, let's take time out, let's go back, let's rebase, let's implement this secure software development lifecycle, they're going to be like, that's going to cost me so much money and I'm not going to get any rate of return out of it. So skipping steps, right? Because you want to be able to make sure that you finish those sprints on time. So how many of y'all have been like, you know what, we'll skip QA here because this is a high priority bug fix that needs to get out today. Cool, we'll do QA on the next release. Cool, I've done it. I'm not going to say I haven't. and then you realize, oh, poo, that was a bad idea. So that takes us into this thing called software development lifecycle. I'm in a university right now, and if any of you are CS majors, right, you've heard of this SDLC. And when you look at the textbook definition of the SDLC, it sets you up for failure. It brings into 3 things that never equal success, which is highest quality, lowest cost, shortest time. From everywhere I've ever worked, you can have 2 of those, but you can never have all 3, right? I can have the highest quality at the lowest cost, but it's not going to be a short time. And if I want that shortest time, I'm paying a premium, right? So that being said, we already have an algorithm that does not work for us. And if it works for you, please let me know, because you need to be on stage telling everybody your success story. So that being said, one thing that I see, and maybe this changed in 2019, but when I went through to get my computer science degree, they were not talking about the secure software development lifecycle. The model was, hey, get through your MVP, let QA, let your internal red team, let your AppSec review find bugs. And then you know what? When they find bugs, they'll kick it back to you, and then we'll just have a sprint dedicated to fixing that. And then you'll get that back, and you'll be like, oh, crap, we have to rebase. This entire function or this entire method or this class, right, is just, or this library that we imported is just, we can't use it anymore. And what it ends up happening is it now costs you even more, right? We'll talk a little bit later about how to mitigate or how to work through this. But at the end of the day, we have to change the mindset, the culture of how we're developing. Cool. So let's talk about this qualitative term called best practices. Every company is going to have their own set of best practices. Some companies are still using Subversion. I know this because I was at a company the other month. They were still using Subversion. Most people have moved to Git. Cool, please don't raise your hand if you're using Subversion. But anyways, what are all these? All these are just centralized repositories that we can all work with so we can collab in on a project to be able to be more efficient, right? Throwing this with a true agile workflow allows us to be not only effective at what we're developing, but it allows us to focus on core features as we're building our application. So I kind of did some Googling. I said, hey, show me the best practices that everybody says that you should do when you're committing code or when you're working with code. And then I highlighted the ones in red that my red team says that they take advantage of. And so the first one is commit-related changes. Cool, that makes sense. Usually how I work, and you're probably the same way, is there's some kind of ticketing, some kind of issue, and then your job is to go in, you typically assign a branch to that issue, and then you work it, then you commit it, you PR it back in, somebody does a peer review, and then it goes into master, right? My next favorite is commit often, right? Where's the security vulnerability behind there? There's really not one, right? It's actually a great methodology, but I want everybody, if you develop code, if you commit, I want you to think about your git commit messages, right? I hear laughing, right? That means you must be like me, nightly. Git message, done. Git message, yep.
Because I said so.
Because, yeah, absolutely. They're vague, right? I believe back in the earlier days, you only had a finite amount of text that you could actually put in a git commit message. So if you're committing often and frequently, right, just like it says you should, and per git, guess what? You're going to have tons of git things, and they're all going to be vaguely expressed. So as an attacker, if my OCO lead comes in and says, you know what, I'm going to insert some code here, git commit -m, cool, space -a, enter, guess what? It's going to just blend in, and it's probably going to make it through that PR, right? We think about it. Think, right? Next one is don't commit half-done work. Well, I blow because I don't ever want to use what work I have in case I swap computers, right? Test your code before you commit. We all do this. I think we're all pretty good at doing this one, right? That's just the best practice that everybody adheres to. Write good commit messages. Once again, we just talked about that. And then use branches. I can't tell you how many developers come into my workshops and they commit straight to master. But then I see how bad I am at not forcing nobody to be able to commit to master, right? I think if you have a GitHub account and you want to make it private, you can't commit, or you can't, you can't prevent people from writing to master unless you pay for it, right? So GitHub's like, you know what, the security feature you really need, you got to pay $5 a month. And I'm like, man, I don't have $5. So the last thing is agreed upon workflow. And for the most part, if I talk to everybody in here, you're all telling me that workflow is a little bit different, right? I mean, does anybody truly work off the verbatim Scrum workflow or Agile, or is it custom tailored to your business unit's needs? Right? Absolutely. Mine's the same way, because at the end of the day, there's bits and pieces that just are irrelevant to us. Cool. So we talked about best practices. Let's actually talk about the attacker side of the house, because that's what this talk was focused around. For those who have never done, those who've never exploited into an environment legally, or illegally here, but we're going to talk about the legal side of it. The thing you first have to ask yourself is, where am I going to land in a network? And if anybody knows where they're going to land, you're a better person than me. We call it the needle in the haystack, which is basically, I don't know where I'm going to land in your network, but I know I'm going to land somewhere. And typically, the first place you land is not the place you want to be. So over time, an attacker will get to those places that they want. So how do they decide where they want to go? It's based off of what they're trying to achieve. And if I'm trying to achieve supply chain interdiction, or if I'm trying to obtain higher permissions, the developer is my key piece. For everybody in here, when you develop, has your IT company told you, hey, we don't typically install that software on your computer? For people that are like, I have to have VS Code, or I have to have Atom, or I have to have Visual Studios, or I have to have .NET, pick a number, right? Typically, the IT department has to bend the rules a little for the developer. Not only do they have to bend the rules, but you're also going to say, hey, I need a dev instance to this cloud instance. And I've seen in many instances like, hey, take this AWS bucket, it's yours and your team's, or hey, take this Azure instance and do whatever you want with it. And then you're like, okay, now I need some kind of data to work with. And it's not good practice, but how many times they say, okay, just use the real database, but don't write changes to it. And you're like, okay, cool, because it does give you great data to work with to build your application. But once again, you take a step back from the security side of the house. The security team says, okay, well, now you have local admin on your machine so you can install all the tools you want. Now you have access to production data. Now you have access to your own AWS instance, right? So you can develop on. Now you're starting to look at this and you're like, oh man, these people actually have a lot of access in our network. That's what entices attackers to their machines. This is my GitHub, by the way. GitHub.com/chiefychief. You'll see a lot of exploits, prototypes. You'll see a lot of half-worked applications. Feel free to make them work. I would love you for it. The next piece is when an attacker gets in that environment, they want to survey the landscape. So once again, as a developer, what you need, right? Sometimes you use sed, you'll use grep, you use git log to figure out where you're at in an environment. You'll use git branch or git checkout to see what you're working with. Guess what? An attacker uses those same exact thing. This is the exact line I do when I get on an environment, because it allows me to know where we're at with that branch we're working on. And here, I can see that on my Recon app I'm working on, they've integrated Open LDAP and current user works. Cool, I don't know what that variable is, but I'll probably find it out as I look through the code. I'll see that they're making it work. Don't know what that is. And I see that they've carved out the template. Once again, I don't know what that is, but now I'm already starting to see that, hey, they don't commit well-defined code, right? Or well-defined messages, as you would call it. So now I know what I'm working with. I also see that this is an active going through their code. As an attacker, many times I take screenshots. I can video record what they're doing, and I can just sit back and see what they're working on. Whenever they call it a day, then I just go in there. In this instance, they were working on the login page of an application called Scoreboard. Right? I saw that everybody hits this page to log in. And you know what? I said, in these comments, I'm just going to insert or inject the code that I want to happen. In this situation, I said, hey, let's put an iframe here. This iframe will go back to my malicious site, and then my malicious site will survey them and try to inject any malicious code I can. Cool. If that's making sense, that's how easy this is. At this part, all the attacker has to do, write some git commit message, right? I said finished implementing LDAP. That way it blends in. It added 1 file change, 5 inserts, 4 deletions. I think I had some new lines I removed. And then I git pushed it. Because nobody has their token saved to their desktop, right? Yeah, yep, exactly. So that being said, at this point, the attacker sits and waits. Because if everything goes according to schedule, that code will somehow make it into master. It might not be the next day, it might not be a week later, but it will eventually make it in there. And at that time, all they do is they have a C2 set up, and now they're just catching callbacks. Once again, once the attacker has done what they've done, and they've been detected by the defenders, they will go back and they will be able to say, at this time, somebody committed this code, and they'll be able to trace it back to that time, and they'll be able to see who did it, but it will never say the attacker did it. It will only show the developer who committed their code. So once again, now you're having to question, is this insider threat? Is this remote? Where are we at? So once again, from an attacker, this is gold because I now have an unlimited amount of exploitation that's going to happen. Once again, the ASUS Live update, the CCleaner are prime examples of how exploiting one little bit of code has expanded them to hundreds of thousands of machines. This takes us to mitigation strategies, because you never want to just say, hey, here's a problem, you figure out solutions. Right? There is no end-all, be-all. There's no silver bullet here. I wish there was. At the end of the day, I can tell you the two things, actually there's three things, that I would recommend to make the right moves. The first one is training. Training, training, training. And it starts at the earliest stage. What I tend to see is people implement that SDLC and then they add the security onto the end. Guess what? If you look at the security SDLC, you'll see that the first thing is training. Make sure everybody in the party, to include management, understands their roles and responsibilities, what permissions they have. Make sure least permission is adhered to. You know, it's much easier just to hook somebody into a production database. It actually is painful to create test data, right? It's a pain in the butt create unit tests, right? But guess what? If we spend those weeks it takes to build the initial unit test, guess what? We're not going to be exposing that critical and sensitive data to the attacker if that machine gets compromised. The next thing is culture. Right? Get out of the mindset of I need to get this product out and change it to I need to get this product out safely and securely. And what you'll find out is it's not really costing you too many cycles. So what does this mean? Forcing people to adhere to actual workflows. Make sure we have software assist where needed. I can tell you that whenever I get ready to commit anything into master, it runs through a few checks to make sure, one, I'm not stealing other people's codes, so that way we don't get sued. Secondly, make sure that none of the libraries I'm using are outdated. And the next one is set it up in a test environment and make sure it executes without throwing an error, right? Just basic checks, but this is something that most software-assisted tools have. And by having those three things, it makes it a lot more secure, minimizes my surface area, right? The one thing I don't have up here is leadership. This is all clutched on having leadership and the buy-in and everybody knowing expected results. Cool. So that being said, I would also hit off with training if I didn't say that already. Let's head to the demo, right? Originally, I wanted to be able to do this demo with 3 screens. I wanted to be able to show you the attacker screen and what the attacker does. I wanted to be able to show you the developer screen and what the developer saw. And then I wanted to be able to show you the clients that went to the app and downloaded and got infected. Turns out that's a lot of screens, and that's really hard in this kind of environment. So what we did instead is we already assumed breach. Let's not worry about how the attacker got it on the box. They got it on the box. Ooh, that's probably bad quality. Let me know.
Victim was spearphished. Clicked on malware inside of email, and it.
So what we're looking at here is I have active session on this machine. Once I have an active session on the machine, the first thing the attacker is going to do, and sorry if you can't see, green I thought would show up a little better, is you're going to survey the environment. When I start surveying the environment, if I'm on a developer's machine, typically I'll see things like .NET, or I'll see VS Code, or I'll see Visual Studios running. And then at that point, I do a directory search of the entire system looking for .git. Right? And if I find a folder with .git, then I at least know that they know how to pull Git code. Then I start looking for those folders and seeing if there's repos inside of them. And if there's repos inside of them, the next piece that I want to do is I want to see if they're actually using them. Because many times people go to Git and they'll just download it to do what they need to do, and they're not really writing back to it. So here you can see I found that directory called repos. I now hop into a shell. And on the shell, I now have command line on that developer's machine. I see that they're working on 5 different applications, or that they at least have downloaded 5 different applications. And then I say, hey, let's go into one of these, because the timestamp shows a very recent modification. At this point, they have went inside this application. I've looked and see, hey, it's a Python app of some kind. I'm hoping it's Flask or Django, because I'm pretty familiar with those. And then I start going to where I know code will be written, right? Startapp.py was a prime example. Go into blueprints, see the endpoints that get called into here. Fast forward a little bit, I find the right file, right? And on this file, I find the actual login portal for the scoreboard application. And I say, cool, I know everybody has to hit this page. Once again, sorry about the green. As I find the exact function I want to modify, I make sure the developer is not currently writing to that. Because if they write to it and I write to it, then they might find out. So what I'll do is I'll wait till they go to bed, right? Or I'll wait till they have a slow time that they're not doing anything. I'll check that Git log. Once again, we now have a long list of a developer who writes really bad Git commit messages, which might be me. We'll then translate that into, let's download the file. Let's make our modifications here. And in this scenario, all I'm doing is I'm opening up a new file, and then I'm writing the username and password in plain text into that file. Right? And then I could have that file shipped off to a server every hour, every 2 hours, every time somebody writes to it. And then as attacker, I win. At that point, I'll re-upload it back to the target. I'll do a new commit message, and then I'll push it. Many times when you push, you don't have the ability to PR your stuff directly in without some kind of peer review. If you're working in a development shop that you can commit, push, PR, and release without any verification, you're probably doing something wrong. By the way, I've been in those environments. And then at that point, I sit back and relax. And as you can see, master has been updated. So now the next time this gets deployed to a development instance, I start infecting people immediately. On that note, do I have any questions? Yes, sir.
From an attacker perspective, how would, for instance, code signing slow me down?
Code signing would definitely slow me down. But if code signing is implied, then I probably have many more obstacles in place to be able to get me to that next step. Yes, sir.
I was just going to mention, does it always, right? Because sometimes with the code signing, it's done after build.
Very true.
In the source, right?
Yep.
So it depends on what part of the build you're in.
Yep, but I would say if you're at code signing, right, if you're already implementing code signing, you probably already have a better process than most. It will slow us down, and typically what we'll do at that point is we'll start trying to survey the landscape to see if we can get into one of the other assemblies that are getting passed in that might be bypassing code signing. Because once again, not every piece of the code or the application has to be signed, right? Just each of the pieces that you're applying the code signing to. Yes, sir.
So just thinking through this process here, your demo, you actually went into a file the developer is actively working on, added some code to it. What about, instead of going something like that, adding a module like NPM modules that nobody ever looks at, adding that in the JSON file, having to pull it in,
Yeah, absolutely.
even further below the radar.
Yeah, does anybody here write Golang? You can pull directly from GitHub, right?
Yes, GitHub.
Oh, thank you so much.
GitHub.
Thank you so much. If you write Golang, right, you can have it always check GitHub for it, right? And change in that little library. Or like you said, if we have different system paths that we can play with, then importing other libraries, changing NPMs, yeah, you don't have to attack their source code, but you can attack one of the libraries that are going into it. Absolutely.
Write your own and just add a line importing that, and then you've got a whole module that you could write.
Yep, and then it's expandable.
Yeah.
Yeah, absolutely. Once again, sky's the limit of where you can take this. And I'm not saying this is how ASUS got compromised or ASUS got compromised. I'm not saying this is how CCleaner gets compromised. I'm just saying this is what my red team, all those people in blue over there, this is what they do when they get on a developer's machine, if it's in the scope of work.
What sort of frameworks are you using? You said using frameworks to scan through the code and see if you're, for example, plagiarizing or whatever.
Oh, yeah. So there's a few out there. So at my previous company, we used Circle CI to help with the build and making sure it's getting to the test instances. Drew Dennison, I can't remember what his company's called. He'll shoot me for this. But he actually has a company out in Palo Alto that goes through all your code, looking for the plagiarisms, looking for outdated libraries, matches those to known vulnerabilities, and shoots you back, hey, this is bad code, or this needs to be updated. Thanks. Good questions on those. What else do we have?
So you mentioned checking for making sure your code was not already somebody else's code. What are you doing for that?
So this was that, I think you asked this very similar question. So my friend Drew Dennison, once again, I messed up I forgot his company's name, and he will shoot me. But anyways, he has a company that actually goes through, it scans it, it compares it to a bunch of different libraries. I want to say that a company that starts with Git, ends in something.com, might have worked with him or doing similar things. Okay, awesome. Lastly, I want to say thank you all for attending. And for those that asked those 2 questions, please, I got something up here for y'all. Everybody else, I have some swag, I have some coins, I have some stickers. If you have any other questions about development, just think to yourself, hey, if I was an attacker, would I be doing that? Awesome, thank y'all.